So this is a video about analyzing and identifying proportional relationships. So we're given this example here where 4 oranges cost $7. So let's write that down. Alright, so you can buy, we're going to set up a relationship and we're going to see the price per orange. So we're going to have price per orange, so that's dollar per orange. So it's $7 and 4 oranges. We'll have O for orange. Alright, so $7 for 4 oranges. That's going to give us our price per orange. Okay, so let's pull out our calculator. And 7 divided by 4 is 1.75. So it's $1.75 per orange. Now let's see if these are proportional prices. So we have, you can buy 7 oranges for $12.50. So all we have to do is multiply this price per orange that we have with this ratio. And so we're going to get the price per orange and multiply that by 7. And if that dollar amount is anything other than $12.50, then they're going to be different. It's not going to be proportional. So let's pull out our calculator again, and we're going to multiply that by 7. Okay, so the price for oranges is not the same. Okay, so we know it's not the same. Now let's kind of put this the other way so we can kind of see where the proportion is equal to with the 7 and the 12. So if we have 7 oranges for $12.50. Okay. So $12.50 divided by 7, that is $1.79 per orange. So we can see that they have different per orange values, so they have a different value. Alright, let's try another one. This one's pretty similar. Okay, so 4 oranges cost $6. So $6 will buy us 4 oranges. And that is, what, $1.50 per orange. That's $6 divided by 4 oranges. So this is $1.50 per orange. Now this, we have another one over here, $15 for 10 oranges, and that looks like that's going to be proportional because it's going to be the same ratio. So 15, oops, that's, so 15 divided by 10, and that's also going to give us a 1.5 ratio, so that's also going to be $1.50 per orange. Alright, so we got a different problem here, that's good. So a rectangle's height is 5 centimeters, and rectangle B's height is 12 centimeters. Okay. They both have the same width. Alright, consider the relationship between the areas of the 2 rectangles if their width changes. Is the relationship between the areas of the 2 rectangles proportional? To find out, fill out the tables with the missing values. Okay, let's check this out real quick. Alright, so let's say the width is 1 for both of these in this scenario. So the area would be 5 times 1. So that's going to be 5 square centimeters. And then over here, we're going to have a width of 1. Where'd my... Won't let me write. Okay, so a width of 1, so 1 times 12 is 12. And then with 2, so 2 times 5, a length of 2, or a width of 2 times a length of 5 is going to be 10. And then 12 times 2 is 24. Alright, and we see that they're both increasing at a proportional rate. And you can really look at this by dividing the top and the bottom right here. So 5 divided by 12, that's 1/2, and 12 divided by 24, that's 1/2. So those are the same ratios there. So it's a proportional relationship. All right. Now let's try this out. Okay, so Bob's chocolate factory is expanding. He wants to know how many workers he needs to produce enough chocolate bars, and then the table here lists the number of workers to produce a particular number of bars. And we're asked to see, is the relationship between the number of workers and bars proportional? Okay, so we can do this pretty easy. We can divide, how many bars each worker does. Let's do that way. So we'll do bars per worker. So that would be bars over worker. Let's get that out of the way. Okay, so bars over worker over here, that would be 40 divided by 10, which would equal 4. So this is saying that every worker, for every one worker, they can make 4 chocolate bars. And so over here, 75 divided by 20 is 3.75. So already we see that there's a difference. So 75 divided by 20 equals 3.5. Alright, at this point we already know that they're not proportional because we already have a different number here. But if you wanted to continue, you can do 480 divided by 160 and 260 divided by 80 and see how close they match up. Okay, does the relationship between degree Fahrenheit and Celsius, are they proportional? Alright, well we can do this either way. We can divide Celsius by Fahrenheit or divide Fahrenheit by Celsius. It doesn't matter as long as we get the same number. So let's do Fahrenheit divided by Celsius. So let's do 41 divided by 5 over here in the calculator. And that's going to be 8.2. So 8.2 degrees Fahrenheit per degree of Celsius. Alright, so let's try another one. So 45.5 divided by 7.5. Now we see that that's already different. 6.07. 6.0 degrees Fahrenheit per Celsius. And if you know the relationship between Fahrenheit and Celsius in reality, you'd know that it's not proportional anyway. Okay, so not proportional. Awesome, we got points. Alright, so hopefully this video helped. If you have any questions, just let me know.